Hi guys, after literally 1 year since my last video, I just had a beautiful baby in the meantime. But even if late, I'm here to show you 3 ways to move a walk cycle or a run forward in the space and how to avoid the slides of the feet. This video is meant for all the beginners animators that struggle with these topics. In the last tutorial, I'll show you how to create a walk cycle in place, and in this first video, I'll explain you how to transform it in a cycle moving forward. First, a sharp premise. You can find some tools that can anchor the feet on the ground with simple steps, but this video is to show you some manual solution that can be useful in case you can't use automatic tools. In my opinion, you will be a stronger animator if you learn how to solve problems even when you have nothing more than your knowledge and brain without tools to help you. In this video, we'll see 3 different ways to move forward a walk cycle, moving forward the main control, using locators, and transforming the cog and feet curves from an in-place cycle in a progressive forward movement. Moving forward the main control. This one is the easiest and fastest way to move forward a walk cycle animated in place, and is useful for simple and straight walks. We start from a walk that happens on a spot, and the feet slide and move back and forth. This is a looped cycle, so as you can see, the animation happens in an infinite loop. To move the character forward, we can select the main control or another control that moves the entire body, and we translate it forward in the space. What we see now is that the character is actually moving forward, but if we look at the feet, they are literally sliding on the ground. To fix this, all we need is a mathematical calculation. We need to determine the exact distance covered by a foot in one single step. During a walk, the foot forward movement covers the same distance of the backward movement. Example, the foot moves backward from 5 to -10 units, covering a physical distance of 15 units, and moves forward from -10 to 5, so it covers again 15 units. So 15 units is the distance covered in one step that we will apply to the main control. The only difference between the forward and the backward movements are the timing and the spacing. They can happen in different timing. In this walk, the foot moves backward in 16 frames and moves forward in 10 frames. And they also have different spacing. In the backward movement, that is when the foot is stuck on the ground, the curve is always in linear tangents, so it has no variations in the speed. In the forward movement is always in spline tangents, so it has is in and is out in the movement. Remember, when we calculate the distance covered by one foot, we always sum the starting and the ending pose values. Usually, the extreme foot backward position is below 0, like in this case that is -10, so we sum 5 plus 10, and as we already seen, the result is 15 units. So, to move the character forward using the main control, we need these values from the foot backward movements, distance cover, timing, and spacing that we will apply to the main control. We use the values of the backward movement because it's the moment when the foot is stuck on the ground, and to avoid the sliding effects we need to apply these same values, distance, timing, and spacing to the main control. So we already calculated the distance cover, that is 15 units. The timing from the foot backward movement is the frame range from the contact pose at frame 1 to the extreme backward position, considering up to the last frame where the foot is still touching the ground. In this case, it's still touching it at frame 16. So the timing is 16 frames. The spacing is easy to know because we need the same spacing of the backward slide of the feet, and we know that this movement is always in linear tangents. So this is the type of tangents we will apply also to the main control. So we select the main control and we set a key at frame 1 where the foot backward movement starts, and another key where the foot backward movement stops at frame 16. On this frame, we apply to the main control the same distance covered by the foot, so 15 units. And in the graph editor, we transform the curve in a linear tangent. Now the main control has the same values of the foot backward movements, same distance covered, same timing, and same spacing. We can see that the foot doesn't slide anymore, but it lasts for just the first step, because we need to add a cycle also to the main control. We can just add a simple cycle like for the rest of the body, otherwise it would pop to the starting position at any steps because the starting and the final pose of the main control are not the same. In this case, since we need to move progressively the main forward in an infinite loop, we need to use the cycle with offsets. The cycle with offsets creates an infinite loop, but anytime this cycle finishes and starts again, it sums the values of the last frames to the values of the first key of the original curve. So the following cycle starts from the values where the first cycle ends. As you can see, it creates this curve that has a progressive increase of the distance covered. So the main control moves progressively forward with the same values of the feet and they don't slide. Now the body is not in place anymore, but is dragged by the main control forward in the space. So this was the easiest and faster way to move forward a cycle in place, and as I already said, is useful in simple and straight walks. If you have something more complex, I'll explain you the other methods in the next videos. Subscribe to my channel if you like and support this project of free animation lessons and tutorials by giving a like and sharing my videos.